Hey everyone, it's TJ with Avidyne. In the following brief video, we're going to be discussing IFD interfaces with the analog autopilots. As always, nothing in the video you're getting ready to watch here can be construed as approved data. For approved data, go to the IFD installation manual. Make sure you're looking at the latest rev. This is for reference use only. So jumping right in, most analog autopilot interfaces with the IFD are going to fall into one of the following categories. You're going to be IFD outputs are paralleled to the autopilot and an analog indicator, or the IFD is tied to a PFD or an EFA system of some type, and the PFD itself is driving the autopilot via analog. There are also some scenarios where the IFD will be connected to an EFA system via airing 429 and also send some analogs out to an autopilot. So it kind of depends on the installation. But for the purposes of this video, we're going to be focusing pretty much on the analog outputs and how that analog interface works. Okay. So this gives you a pretty good representation of what most of the analog installations look like with analog CDIs. So all of your, main left, right, main up, down, lateral flags, vertical flags, all of that good stuff gets paralleled generally between the IFD and the indicator itself. In those installations, it's actually really nice because that actually gives us some additional things we can do to troubleshoot if we have a problem after installation. So we'll dig into some of those here in just a few. So let's start off by looking at our main left-right deviation info. So that's coming out of the same pins that are driving the main left-right to the CDI. It's 150 millivolts for full-scale deflection. Since voltage is constant and parallel, those inputs on the autopilot should match exactly what the input on the indicator reads whenever these are paralleled like this. So we should be able to go into maintenance mode on the IFD, go to the main CDI OBS config page, and drive the needles left and right, and see the needles move left and right on the indicator, and go to these pins on the autopilot for our lateral deviation left and right and measure those, and we should be able to see 150 millivolts plus or minus for full scale deflection. Those measurements should be taken at pins themselves. That 150 millivolts is in reference to the other line. So the left and right, it's going to be in reference to one another, not reference to airframe ground. So you would want to measure the outputs from pin 21 and 22 against each other. So 1 meter lead on pin 21 output, 1 meter lead on pin 22 output, and then measure that voltage there. That's where you would see the 150 millivolts. For your main up down, same thing, 150 millivolts for full scale deflection. And we should be able to see that on our connected indicator as well if that's paralleled in. Our main lateral flags, these are low-level valid flags. It's 120 millivolts for the flag to leave the stops and 260 millivolts for the flag to be fully concealed. Again, not all autopilots are going to use these, but the ones that do should match exactly what we're seeing on the connected indicator as well. Main vertical flag, same scenario, 120 millivolts to leave the stops, 260 millivolts for the flag to be fully concealed, and again, should match exactly what we're seeing on the indicator. All of those analog outputs can be driven from right here. As I had mentioned on the main CDI OBS config page, we should be able to go there and drive our needles, left, right, up, down, as well as our flag outputs from here and go out and measure those at the autopilot itself. Some analog autopilots also have the capability of doing GPSS roll steering, And in those cases, we would go ahead and send it a GPS ARINC 429 output. And that's going to be any of the gamma varieties will work fine with GPSS. And some analog autopilots are actually going to be monitoring the discretes as well. So when you go into approach mode, a lot of times the old analog autopilots will listen to that discrete to know that you're in approach mode, and it'll crank up the gain on the servos so that you get a quicker reaction times when those seconds count. So that's something to look for, so that the analog outputs from the IFD, when it comes to these enunciations, those are active lows. So when the IFD goes into approach mode, for instance, pin 14 would put an active low on that line. So you should be able to see a ground out there at the autopilot under that sequence of events. Some autopilot systems will use super flags. Super flag is going to provide bus voltage when it goes valid. So it's either 14 or 28 volts, depending on what your airframe bus voltage is. And there are some instances where you might have an autopilot system that can listen to either super flags or low-level flags, as you can see here. What you want to be careful of is that you don't use both low-level flags and super flags on the same autopilot system, unless it was specifically designed to take both. Using both can usually, cause some damage, so you want to avoid that. Typically, it's pick one or the other if you've got an autopilot that can use both. There are also some instances where we've got an analog indicator using low-level flags and an autopilot that uses super flags, and that's totally fine. You can absolutely do that. Big thing to keep in mind is if you're wiring both low-level flags and super flags to the same component, be it an autopilot or an indicator, there's a really good chance it was not designed to take both. So there's a possibility there that you could do some damage. And as you can see here, many of these analog autopilots are not going to use all of those analog outputs. It just depends on what the capability of the autopilot itself is. So as an example, here's a Bendix King autopilot interfaces from the installation manual. If you look right here at the CAP 100, it can do main left right, and it takes the approach discrete, and that's it. So you're not going to get any kind of vertical guidance out of that. You're not going to get any of that kind of stuff. You're going to get main left right. That's it. That's all you're going to get. It's not monitoring flags. It's not looking at vertical deviation info. It's not doing any of that stuff. And then compare that over here to a KFC 300, for instance. So there it's monitoring the flags. It's doing main left right. It's doing glide slope up down, as well as discretes. So it all kind of just depends on the autopilot itself as to what the full-on capability is going to be. As you can see here, we've got the KFC 225 takes ARINC 429 as well. So we add that in. So again, it's we oftentimes get a lot of phone calls and tech support. Hey, will the IFD work with such and such an autopilot? If it's an analog autopilot, the answer is almost always yes. But be aware that there are some capability limitations depending on the autopilot. So same story here with some of the S-Tech autopilots. The older System 20s and System 30s, they're not going to give you the vertical component. They just weren't capable of it, right? So those limitations are still going to be there because the autopilot itself doesn't know what to do with that information. And then as you can see here, here's your collection of Century autopilots. So same sort of thing. As you notice, kind of the older the autopilot is, the less likely it's going to be to have a vertical component. And that's fine, but that was the design of the autopilot. So the IFD is definitely going to send that information out, but if the autopilot doesn't know what to do with it, it's not going to be real useful. For VOR deviation, so this is something to pay attention to as well. We do get phone calls about this once in a while, so it can be kind of a gotcha. So if we're using the analog outputs to drive the autopilot, the only way deviation data to the autopilot gets calculated is based off of current selected course information. So we want to make sure that if we're doing an analog installation, with an analog indicator and an analog autopilot, we got to make sure that we go in and actually calibrate that selected course info coming from the indicator. Otherwise, it's going to throw off what the deviation data is when you go into a VOR or an OBS mode with the autopilot. And assuming the autopilot does not have a GPS button, a lot of the older autopilots are just going to have a nav mode, So the way that would generally work, if we're connected to the P1001 connector, is you would put the autopilot in nav mode even when GPS is the selected nav source, because it doesn't have its own button, so to speak. So you would just fly it like a normal nav and drive it using GPS coming out of the IFD. Something to keep in mind there, though, is that if we're using analog outputs to drive the main left-right of an autopilot out of the IFD, even if we're flying along in GPS mode, it's not going to put out turn anticipation information on that main left-right. So if you've got a flight plan where you've got a sharp course change in your flight plan, and you've got nav mode engaged and you're in GPS mode on the IFD, you're flying along, there's a good chance you're going to overshoot any of those sharp intercepts because it's not going to anticipate those turns. It's important to have that conversation with the aircraft owner so that they understand what the expectation is. If they want to have turn anticipation, we absolutely will send that out via ARINC 429. So what you would want to do in that scenario is go ahead and install a GPSS converter for this as well. And we're going to do a separate video walking you through some of the ins and outs of the GPSS converter and how that interfaces with the IFD and the autopilot. And that's pretty much all we have for this one. So as always, if you guys have any questions, comments, or concerns, feel free to shoot them over to techsupport@avidyne.com. And thanks for watching.